Hi, I'm Ed Sperling. I'm the editor-in-chief of Semiconductor Engineering. I'm over at Infineon with Sivaram Trikutam. Going to talk today about Wi-Fi 7 moving to the IoT. Sivaram, we've seen Wi-Fi 7 out in the marketplace for a couple of years. What's changed?
Okay, the Wi-Fi 7 that you've seen over the last 2 years is primarily focused on very high-end applications, high data rate. Think of 5, 10 gigabits per second kind of data rates. Think of applications like virtual reality headsets, enterprise laptops, and so on and so forth. And Wi-Fi 7 brings a lot of benefits to these kinds of applications. But Wi-Fi 7 has a lot of other features which have not been exploited so far in the world of IoT, and that's about to change now.
Well, let's take a closer look.
Sure.
Sivaram, what are we looking at?
We're looking at how a typical IoT device operates in a home. When I say IoT device, think of door locks, thermostats, appliances, robotic vacuum cleaners, any number of these devices that are getting connected to the cloud.
And so what's changing? I mean, these things have been communicating with the cloud for a long time.
Yeah. So what's changing is the number of these devices in a home, right? So you've got an IoT device in a home. Like I said, this could be any of a thermostat or a door lock and so on and so forth. These connect to the internet through an access point or a router. Now, Wi-Fi operates in three bands. So you could connect in 2.4 gigahertz or in 5 gigahertz or in 6 gigahertz. While it can operate in any of these three bands, provided, of course, the IoT device supports it, at a time it can operate only in one band. So when a device is connecting to the access point or the router, it has to pick which band it's going to connect in, right? So let's say it picks the 2.4 gigahertz band to connect in, then it has to stay connected in that band until the connection is turned down. Now here's the rub. I mean, all this has been the state of smart home wireless technology for a while now. Now, what's happening is these IoT devices are multiplying in a house. So you have multiple IoT devices. You've got nearly most American homes these days have more than 30 devices, and we see by the end of this decade, this number is going to push towards 50. There's going to be a lot of crowding in the spectrum in a smart home. And this is what is going to be addressed. Now, Wi-Fi 6 addressed this to some extent, where it changed the focus from increasing the data rate instead to deal with the network efficiency. But Wi-Fi 7 is going to take it a step further.
So what does that do for IoT?
In this scenario that I talked about, it could connect in any of these three bands. A Wi-Fi 6 device, like I said earlier, has to pick which band it connects in when it makes the connection. With a Wi-Fi 7 device, it doesn't have to make that choice. It can connect in all three bands at the same time. So think of it as three simultaneous connections between the IoT device and the access point. So you've got three different logical connections at the same time, right? Now, of course, you will use only one of them when you have to transfer data back and forth, but all three connections are established. So say an IoT device, like let's say security camera, it gets triggered, it has some data, some video feed it captured, it needs to upload. And when it has to upload, it finds that the 2.4 gig channel is busy because somebody else is using it at that point. With Wi-Fi 7, what you can do is just quickly switch to the other band. You don't have to establish another connection, it's already established. So you can just switch to another band, shoot your data off in that channel, and you're done. So you're avoiding being stalled in a congested network by creating multiple alternate paths through which you can transmit your data.
Can it self-regulate the amount of bandwidth that's allotted to multiple devices that they're all competing for?
Yeah. So the access point can actually do that. The access point, provided the IoT devices are Wi-Fi 6 or better, it can actually regulate because Wi-Fi 6 has the ability to schedule traffic. But if you have a lot of legacy devices, which is the case in reality, like if you look at let's say a smart plug, right, in your house, and I'm just using that as an example. These are like these tiny little plugs people put in their homes, and there are like tens of them. These all tend to be Wi-Fi 4, so you can't regulate regulate those. So the presence of a lot of these legacy devices actually makes the problem worse. So those can't be regulated. But in this scenario, the IoT device can self-select which of these bands that it uses to make the connection.
So why now? What's changed that suddenly we need this in the home?
Okay, so in the home, first, I mean, what's changed is, like I was saying, the number of devices, but also what's changed is the enabler. Okay, so Wi-Fi 7 so far has been primarily focused, like I was saying earlier, on devices like laptops and so on, which laptops and VR headsets, high-end audio and so on, where the accent is more on the data rate. So in this case, what you do is you use multiple Wi-Fi links, let's say 6 gigahertz and 5 gigahertz, and combine them together. So you basically combine these to increase the data rate. That's been the focus of Wi-Fi 7 so far. Now, the Wi-Fi Alliance, having realized that there are a lot of IoT devices and the impact that the IoT devices can have in a smart home, has now extended the Wi-Fi 7 standard to cover IoT devices, which are basically 20 megahertz devices. Right? This is the lowest channel bandwidth that you can implement a Wi-Fi product in. So the benefits of Wi-Fi 7 have now been brought to the world of IoT devices with the inclusion of 20 megahertz devices in the certification program. So these devices are a lot simpler. They don't do a combination, which is like, think of it as an and, you're combining links. Here it's more of an or. So you bring a lightweight Wi-Fi 7 into the world of IoT at the right cost point that these kinds of devices need. And that's just recently happened with the Wi-Fi Alliance adding this to the certification program.
Are there any bandwidth limitations here like there are, so spectra for cellular, for example, is that the same as it would be in Wi-Fi, or is it very different?
Well, the big difference is between cellular and Wi-Fi. Cellular operates only in licensed bands, whereas Wi-Fi operates in unlicensed band. But that said, even the unlicensed band is a certain fixed amount. And spectrum is one of the most scarce resources that we have. So in the 2.4 gigahertz, for instance, you have just about 100 megahertz. In fact, even less, about 80 to 100 megahertz. 5 gigahertz is a little more than that. 6 gigahertz is a little even more than that. But you're still limited by the spectrum that the various regulatory bodies belonging to various governments allocate for such unlicensed usage.
So what I'm thinking of, okay, so you've now gone from 30 to 50 devices in your home, and now suddenly all your neighbors are going from 30 to 100 devices in your home. Is there enough bandwidth available to make this work?
Yeah, so bandwidth, yes, but the challenge here is how to use that bandwidth efficiently. So what ends up happening because of the way Wi-Fi works is it's basically a self-regulating mechanism. So devices compete for the bandwidth in a fair way, and everybody gets allocation of the bandwidth. Now, those mechanisms don't work very well as the number of devices grow, because people are competing and there is wastage because devices compete for the same slot and nobody ends up using that slot to transmit. So that problem gets exponentially worse. So if you look at, let's say, the congestion, and this is a very simplistic picture of this. If you look at congestion versus the number of devices, it doesn't grow linearly. It grows exponentially, right? So as the number of devices crosses about 25 to 30, the problem starts getting really, really bad. And that's where Wi-Fi 6 and eventually Wi-Fi 7 for IoT helps alleviate.
And what happens with Wi-Fi 8? Where does that go with this? Is it just faster, or is there actually better use of that spectrum?
Okay, Wi-Fi 8 is still being defined. There are things that are going to change in Wi-Fi 8 over the next 2 years. But the accent since the Wi-Fi 6 days is not just on making Wi-Fi faster, which was the accent, by the way, from Wi-Fi 1 to Wi-Fi 5. It was all about making the car go faster. And when it came to Wi-Fi 6, the industry realized, what's the point of making a car go faster if it's going to be stuck in traffic all the time? So since Wi-Fi 6, there are various techniques that the industry has been developing to increase the efficiency of usage of spectrum. Wi-Fi 6 made a big step in that direction. 7 took it further, and 8 is going to take it even further in that direction.
So there's efficiency to close up in every aspect of this, right? That's really where you're grabbing from. It's not that you're increasing the spectrum. I mean, what you're doing is saying, okay, we can make everything here more efficient.
Exactly. The spectrum remains the same. You just use the spectrum more efficiently. Yeah.
How much efficiency can you get out of this? I mean, is this like Moore's law where you keep shrinking down and down and down, and eventually you run out of space?
Yes, there is eventually a limit to it. In fact, the equivalent of Moore's law there, the information theory equivalent of that is the Shannon's law. So you're ultimately limited by the Shannon's limit, which for a certain bandwidth, there's only so much data you can carry in it. We are far from hitting that limit. We'll keep making improvements, but yeah, ultimately we'll hit the limit.
But this is just one of a number of wireless technologies that's available too, right? Where do the other ones fit in? So you've got cellular, you've got potentially satellite as well. There's all sorts of new things that can come in here too.
Yeah. So in the home, though, I mean, we started talking about home. So Wi-Fi is a very common technology in the home. And you've got 802.15.4, which is thread technology, which for sensors and so on is a technology that's getting adopted. So that plays into the what you might have heard being referred as the Matter ecosystem. Now, the technologies you mentioned, those are generally not used in the home context. They are more industrial context. So think of, for instance, gas stations or industrial logistics, transportation, and so on and so forth, where you can't depend on the availability of Wi-Fi. Cellular is a much better fit for those kinds of use cases. But if you're operating in the confines of a home or in an enterprise environment, shopping malls, and so on, where Wi-Fi is ubiquitous, it's generally the technology of choice for implementing applications that require connections to the cloud.
As you go up in terms of Wi-Fi 5, 6, 7, does the security improve? Does it go down because you have more potential devices that are there to be hacked?
Yeah. So the security for Wi-Fi has also kept pace, right? So when we moved from 5 to 6, new security features were added. Now, security is a very complex topic, though. For an IoT product like this, you need multiple levels of defense. It can't be just one level of defense. Like, for instance, if you take the analogy of a home, you need to have the gate secured, you need to have the door secured, and once you're inside the house, you need to have your safe secured. These are all different levels of security. Now, Wi-Fi is the entry point into some of these devices, so obviously that needs its security. And as the standards have evolved, there are corresponding security standards which go by the names of WPA2, WPA3, and so on, which increase the levels of security in Wi-Fi, and then the IoT products have to implement additional security measures in order to secure the device completely.
This has been used in price insensitive markets, less sensitive than what you're dealing with right now. Does the cost go up as we move up from Wi-Fi 6 to Wi-Fi 7?
Very good question. So when you move from Wi-Fi 6 to 7, like I was mentioning this earlier, there are different types of Wi-Fi 7. The Wi-Fi 7 that's been in the market so far have been for high-end applications like this, where you actually have multiple connections and you combine them. When you combine them, the chips are more sophisticated. They need to be more complex. They're bigger in size and so on. The system also gets more complex. The number of components that are required on the board in order to implement the Wi-Fi subsystem also gets complex. So these are expensive. And now with Wi-Fi Alliance bringing Wi-Fi 7 to the IoT devices, where we're implementing a much simpler form of Wi-Fi 7, which is more suited for IoT devices, this comes at practically no additional cost. So a lot of benefit. You could think of it as 3 times the reliability. That's instead of just connecting in one band, you can connect in 3 bands at the same time. So you have roughly 3 times the reliability of a wireless connection at practically the same cost. You don't have to add additional components to the system.
Sometimes there are hidden costs there though too, right? So you think about power. If you're using more power, the cost goes up, but you don't necessarily see it in terms of what you're buying in bandwidth here. Does that go up with Wi-Fi 7 as well?
There are 2 aspects to power. One is the standard itself, right? And in fact, Wi-Fi 7 has some features which actually help reduce the power, particularly for devices that are not used very often. Like if you think of a security camera, it's just sitting there, staying connected, but you might use it 10 or 20 times in a day. So devices like this, which stay connected but are used infrequently, Wi-Fi 7 has features that actually reduces the power. Now, the other aspect to power is the implementation, which is irrespective of the standard. How well does a semiconductor supplier implement the standard in order to get the most power efficient designs? And now what you're finding is the industry is moving further and further in that direction, where you have a lot of battery operated devices operating on Wi-Fi. The examples I gave earlier, door locks, which should be able to run more than a year on a couple of AA batteries, cameras that don't have to be charged every 2 months. I mean, you have to climb up and pull the camera down and charge it. No, you don't have to do that every couple of months. There are products in the industry now that are sub 100 microwatt stay connected power. So the industry is moving in a direction where all manner of battery operated devices can operate off of Wi-Fi.
With Wi-Fi 7, though, you expect to have more efficiency. Does it, as we go down to devices that are 6 or 5 or 2.4, do they now consume more energy still?
The legacy devices, I mean, it's not so much to do with the band, but power is also a function of the silicon technologies that are being used. So generally speaking, the older legacy devices, the Wi-Fi 4s and the Wi-Fi 5s, were built in older silicon processes, let's say 65 nanometer, 40 nanometer, and so on. The newer devices are built in newer silicon technologies, which also lends themselves to lower power. So it's not so much a factor of the Wi-Fi standard, it's just the state of the industry that the newer products, particularly the Wi-Fi 7, Wi-Fi 6 products built for IoT, tend to be much lower power than the legacy devices, Wi-Fi 4 and Wi-Fi 5.
So how widely is Wi-Fi 7 adopted at this point in the home? How do you see this actually growing, and what's the future look like here?
Yeah, very good question, because for all the benefits I talked about now, you've got to have the infrastructure to take advantage of it. I mean, Wi-Fi 7 product started shipping about 2 years ago. If you look at the access points and the routers, 2025, the shipment of Wi-Fi 6 devices is still higher than Wi-Fi 7 devices. But Wi-Fi 7 is growing rapidly, right? The industry data forecasts that by 2027 or early 2028, Wi-Fi 7 access points are going to outpace Wi-Fi 6 access point shipments. So we already see a lot of the popular, routers. I mean, examples like if you have an Amazon Eero router in your home, or the new Comcast router in your home, they're already Wi-Fi 7. And in a couple of years, what you'll find is most of the new access points that are shipping will be Wi-Fi 7. So come 2027, 2028, the dominant infrastructure out there is going to be Wi-Fi 7. So if you're starting an IoT product now, if you're starting the design of a product now, which is going to launch sometime in 26 or even 27, it's time to start thinking about how you would take advantage of Wi-Fi 7, particularly the new version, the IoT-friendly Wi-Fi 7 version in your product design.
Sivaram Trikutam, thanks for a great explanation.
All right. Thanks, Ed. Great talking to you.